Hi, this is Brian Winkle, the director of SIMIODE. This is a video about the introduction and overview of SIMIODE web community, and this will be in part one. So here we are at the SIMIODE web page. You can see it's www.simiode.org, and there's quite a bit here. What I'd like to do is log in as a user, although much of what I'm about to show you is accessible to people who don't log in, namely who are not registered. So my username and password is here, and I'm about to sign in. And one of the things you'll see first is the dashboard of the individual, and this is my dashboard. This is my picture at a trip to England, and a number of things about the profile that you can change. This is the contributions that I have made. These are some of the groups that I am in. In fact, all of the groups. These are the projects that I'm in. This is information. And that's just to let you know that each individual will have a presence once they register. And by the way, registration is entirely free. So what I like to do is go to the home page again. Now that I'm registered, you can see the little icon which tells me I'm on. This is a carousel that features several things, including our starter kit, which we will get to eventually. So I thought we'd take a look today at a number of the issues that are here. The first and foremost is the current SCUDM, that is student competition using differential equation modeling, which is taking place with registration through the 1st of April. Here's a powerful video in which students describe their efforts in the SCUDM 2017 we ran in the fall. But let's take a look at these headings up here, and we'll go to them at a future date. But you can see there's resources, all kinds of stuff here. There's information about us. There's support. There's stuff about the community, the groups, a forum. There's a SIMIODE blog. There's a newsletter. There's information about SIMIODE. SCUDM is a 501c3 nonprofit, so you can donate support that way. Let's take a look at the same sort of stuff that's up here in the resources, only they're down here in a readily available format. So the heart of SIMIODE, which is, as you may recall, an approach to support teachers who want to use mathematical modeling and modeling real-life situations in the support of teaching and learning differential equations. So we call these modeling scenarios. These are projects, small and large. And let's take a look at what we have to offer. One of the things we see here is that we have a list of them. There are numbered. These numbers correspond to traditional chapters in a textbook. So all those that begin with the number 1 involve first order differential equations. Here's a way to look at all of the tags. And we can search these if we click on the search button and we wanted to see if we have anything with logistic in it. And what we'll see is, yeah, we've got a whole bunch of things. This happens to be an article. This is another article. But let's say we want to look at the modeling scenarios, namely the actual modeling projects for students. So we could go in here and take a look at one. This one is everything here with a T stands for a teacher version, which actually has the statement of the problem, some presentation, perhaps a pointer to a video, an analysis of data, and then it has comments. Those comments are only in the teacher versions. And if we looked around here, we could see a number of these, and we could pick some. Here's one called The Struggle. We look at the struggle for existence, and what we'll see is an abstract. This is the teacher version. We'll also see over here that there's a PDF. There's additional material, and let's take a look at the download first of all. What this is a statement of the problem. This is the teacher version, so it has an abstract and a set of keywords and tags. This is not in the student version because it may tip the hand more than a teacher might want. Of course, you can always give that out. Here's some data from Gauss's work in the 30s in the Soviet Union on studying several different kinds of yeasts. He was trying to increase the yield of vodka. So this is the data they collected. Here we give several models. Sometimes these scenarios don't propose the models. This one is essentially a competition model. And what we're trying to do is estimate these parameters, and that's what these exercises ask the students to do. The comments for the teacher are rather brief. They essentially say, we have all of this material, solution strategies in a Mathematica notebook and a PDF file, which you can read if Mathematica is not your game. Here's the references as needed. If we went to look for the additional materials, we would see that there are all kinds of things. There's the PDF that we just saw. Every one of these has an underlying TeX or Word version, and so this is the complete TeX code, including a class file that's here, and running a logo for the SIMIODE. And these are the student versions. All of this is downloadable, modifiable according to the most generous license of Creative Commons. So here is the Mathematica version, and here's a PDF version. Here's a Maple version and a PDF version of that. So you can fool around with this. What we'll do now is take a look at several other things. We'll just work our way out here and go back to the home page. A couple of other things we might look into are other resources that we can look down here. And one of them is the potential scenario ideas. There are hundreds of these, as you can see. They're from articles, references, some of which are included, some of which have strong pointers, a large index set. And what these are articles that you might find helping you or your students to do a project and perhaps eventually composing a modeling scenario for publication in our refereed versions of online materials. The other oceans that I wanted to share with you are there's about over 24 free online textbooks for your students that are all public domain, and these are either pointers to them or the actual text. It's probably best to go to the author's source because sometimes they update them, but these texts are all free and online, and they'll save your students hundreds and hundreds of dollars if you use them. Okay, so another thing we have here that you can take a look at is a sample syllabus, among other things. We can take and open that. This syllabus allows one to look at various scenarios, again, in the form of an outline for chapter 1, first order, chapter 2, some more first orders, maybe some integrating factors, notions like that, moving up into second orders, projectile motion systems, nonlinear, linear, all the way through some optimization, even a little optimal control introduction if you want, notions of bifurcation, some pursuit models, predator-prey, some material on Laplace, convolutions, information about Fourier series and PDEs. So there's quite a bit of material here, always looking for more. And if we went further, we could find out starter kit might look like. And this is for folks who are just beginning, and what we have here is materials that are surefire and always work. This is one that involves simulating a death and immigration using M&Ms that's been used by thousands of people. This is the student version. You'll notice there's a statement. It describes the experiment. It describes how to collect the data. We attempt to build a model. We talk about death and immigration in this model. We indicate several models which might work and ask students to begin to shoot them down as to which are reasonable and which are not for modeling this. We build a differential equation, a difference equation, and we actually move to the differential equation. This is all part of the pedagogy of this. And we have an online setup where we have a video that you can use to collect the data, but here are the difference equations, and here are the differential equation solutions, and we can compare that to the data that they might get. So this is an example from the starter kit. And if we go back, we see other examples. Here's one on how long does it take an ant to build a tunnel of length X. Here we have the ant, incredible graphics, and we're building it. And again, we give the students a bunch of models for the time it takes to build a tunnel of length H once you're in it, depth X. And the issues here are that these are pretty much good enough to get you into materials and that you could see how things work at SIMIODE. So we hope you'll come and visit. We'll be talking about more specifics and giving more examples in part 2. Thank you very much.